Hello students, welcome. Previously, Form 3, Lesson 34, we were dealing with the first aim of back titration, which was determining the molar mass of the analyte. So today, Lesson 35, we are going to do aim number 2 of back titration, which is determining the mass in grams of analyte, or of the analyte. Number 1. We are told a piece of magnesium ribbon was dropped into 150 centimeter cube of 0.1 molar dilute hydrochloric acid. The resulting solution required 50 centimeter cube of 0.2 molar sodium hydroxide for complete neutralization. Calculate the mass of magnesium ribbon that reacted. So here we have to know the general procedures or the general steps of back titration. And the first step was we are supposed to look at the number of moles of the alkali, in our case, sodium hydroxide. So we are going to start by looking moles of sodium hydroxide. So the formula for calculating moles was molarity multiplied by volume used divided by 1000. So the molarity is 0.2 multiplied by volume, which is 50, divided by 1000. Here we are going to get 0.01 moles of sodium hydroxide. That's the first step or the first procedure. Second procedure is we are supposed to look the number of moles of the hydrochloric acid that reacted with the sodium hydroxide, or in other words, the excess moles of hydrochloric acid. So that one we can get by writing the reaction between sodium hydroxide solution and also hydrochloric acid. Across. So here we are going to get sodium chloride solution and also water. So let's get the mole ratio between sodium hydroxide ratio hydrochloric acid, because this reaction is self-balanced. The mole ratio here is 1:1. So we have gotten the number of moles of sodium hydroxide, which is 0.01. So we can ask ourselves, what about the number of moles of hydrochloric acid? Here we can say 0.01 multiplied by 1 divided by 1. So here we still get 0.01 moles of hydrochloric acid. So this is the excess moles of hydrochloric acid, or the number of moles of hydrochloric acid that reacted with sodium hydroxide. Next, we have to look for the original moles of hydrochloric acid. The original moles of hydrochloric acid, original moles of hydrochloric acid. Moles is given by molarity. The molarity of hydrochloric acid is 0.1 multiplied by volume, which is 150, divided by 1000. So we're going to say 0.1 multiplied by 150 divided by 1000. So here we are going to get 0.015 moles of hydrochloric acid. So this is the original moles of hydrochloric acid, which is 0.015 moles. Okay, next step, we have to get the number of moles of hydrochloric acid that reacted with magnesium ribbon. So we are going to say moles of hydrochloric acid that reacted with the magnesium ribbon. So this we can get by having the original moles of hydrochloric acid then subtracted by the excess acid or the excess moles of hydrochloric acid. So this we are going to say original moles minus excess moles. So this will be equal to the original moles of hydrochloric acid is 0.015 minus the excess moles of hydrochloric acid is 0.01 moles. So this one will give us 0.005 moles. So this is the number of moles of hydrochloric acid that reacted with the magnesium ribbon. Okay, next we have to get the number of moles of magnesium ribbon that reacted with hydrochloric acid, and that one we can use mole ratio. So magnesium ribbon reacting with the hydrochloric acid, we are going to get magnesium chloride plus hydrogen gas. So let us see the mole ratio between magnesium ratio hydrochloric acid It's 1:2. We're having 1:2. So we have the number of moles of the hydrochloric acid that reacted with the magnesium ribbon to be 0.005. What about the one for magnesium? So we cross multiply, we are going to get 1 times 0.005 divided by 2. This will be 0.0025 moles of magnesium ribbon. So next we are going to get the mass of magnesium ribbon. Mass of magnesium. Mass of magnesium ribbon. Mass will be given by moles multiplied by RAM, the relative atomic mass of magnesium. So moles, which is 0.0025 multiplied by the RM of magnesium, which is 24. This will give us 0.06 grams of magnesium ribbon. That will be the mass of magnesium ribbon that reacted. So we are going to go to the extended question. We are having one question which is an extended question. That's the end of our video.